Welcome to the presentation we prepared for the Asian-European Meeting Seminar on New Technologies for Demining and Human Security, hosted in Taranto and organized in collaboration between the Italian Ministry of Foreign Affairs, which invited us to participate, and the Cambodian one. So the title of this presentation is Appropriate Technologies in Humanitarian Demining, Potential Impact of Participatory Redesigned Agricultural Machines and Tools. So we will see first the newly conceived land release concept, and then we'll overlook at what machines exist on the humanitarian demining technology market and how agricultural machines could be efficiently employed in land release. Then we will speak about our experiences in Genova, about the Snailaid approach, the PART machine that we developed and we prototyped, and two more projects we have written and we are waiting for funding to become available. These are Armadillo and Locostra. And then we will conclude. So 2009 is a very important appointment for the mine action community, as is the first Ottawa Treaty deadline for completing clearance. Therefore, the world should look like this. If all the countries that firstly signed the Ottawa Treaty in 1997 could have finished clearance activities. Instead, 15 of them, which is almost 2 over 3 of them, could not make it. Proving that targets set by the Ottawa Treaty were not too realistic, and forcing these countries to cope with landmine problem for much longer. At the same time, we are assisting at a widespread food crisis that is affecting many of the same countries that are also coping with the landmine problem, and this puts a lot of pressure on the release of land in a quicker and more efficient way. Luckily, at the same time, we are assisting a dramatic change from the requirement of clearing of all mines and explosive remnants of war from suspected areas to the acceptance of a residual risk after clearance, which is a very wide approach, as even if when the most expensive and dedicated equipment is used to process land, nobody can state that the processed area is really free of any explosive device. Therefore, we can introduce a combination of quicker, cheaper, and inherently less reliable methods to approach the problem in terms of risk management. And so the land release concept aims at use sophisticated equipment and very expensive equipment to clear only where the landmines are, which is generally only 3% of the entire area, and process the rest just by gathering and managing information through general survey and technical survey. Technical survey involves the use of some clearance assets and some technology. So machines available on the humanitarian demining technology market generally are heavily armored, highly powered, and high-cost equipment. And the high cost can be due to the fact that these machines are sold on a market which is not a traditional one, but a military-like type. And prices are negotiated in confidence and therefore are not always clear. Then also the fact that these machines are very high cost can be due to the strict requirements according to which they are designed. If we think about the performance test as described in SEN workshop agreement, it foresees that the same machine withstand 450 landmine explosions in the same trial. And this leads to a very limited production. Only 650 machines are operating worldwide according to the GACHD catalog, and these machines are also complex systems because they have to address the biggest variety of scenarios as possible. Therefore, I'm wondering if this machine should be used in technical survey because maybe requirements are too strict and the number of machines is too small. So their use can be reasonable only where there is a high concentration of mines, while we need to research into less expensive, more widely available, and moreover more appropriate machines specifically targeting technical survey. So, by increasing the number of machines in use in technical survey, we can reduce time and cost. If we use this graph to show it, we can use area processed on the baseline and cost and time on the vertical line. Assuming a linear behavior for general survey, technical survey, and full clearance of cost and time per area processed with an increasingly higher inclination from general survey to full clearance, then we can assume that this graph apply. Also, we can associate to the same graph the risk left over after these activities are completed. And to full clearance, we associate a minimum risk left over as the confidence in which the land is released is higher. And to general survey, a maximum risk left over. Okay, by increasing the number of machines used in technical survey, we can shift this vertical line a little bit further, and we can keep on using technical survey to process a bigger area. And this leads to a saving in cost and time, as well as to increase in medium risk area left over, which is not a problem because on the long haul we can process more land at the same time. So my argument is to use agricultural machines for technical survey, and these are the reasons, because the agricultural machines are originally conceived for ground processing. They are largely available and easy repairable. They can be reconverted to original use after clearance. They are mature and modular, and they can help relocalization. That is happening in every field and also in mine action, as programs are handed over to local communities. Moreover, local redesign of this technology can favor human development. If we define human development as achieved when human needs are provided and human capabilities are developed, and if we look into the etymology of the technology word, which comes from techne, art or craft, and logos, meaning not only the result of the process that leads to a new object, a new technological object, but also the knowledge that is behind and the knowledge on how to use it, we can see that there is a strict link between human development and technology. Any technological change can build up human capabilities that in turn creates knowledge, and creativity brings again to another technological change. At the end, this results in economic growth. So, to adapt agricultural machines to technical survey, we need to modify these technologies. Requirements are very simple, as we just need to process ground at constant depth, and we have to design these machines to withstand at least one explosion without being severely damaged, and we want to keep the operator safe. So there are several fields in which we can research. First of all, ground processing tools to be attached to standard linkages or even animals where machines are not available. Then we have to keep the machine safe by providing an armoring and maybe some blast resistant wheels. And we have to protect the operator by providing remote control, or if the machine has to be operated on board, by devising some special shock isolators. These are few examples of what is available on the agricultural market and can be readily employed in mine action, especially the potato diggers. So I make an example of Bosnia-Herzegovina, where in 2007, 170 kilometers square of land were released using 21 machines. This means that every machine had an average productivity of 8 kilometers square. There are still to be clear 1,700 kilometers square. So if we look into the population of tractors available in Bosnia, which is 30,000 units, and if we assume that each one of these tractors opportunely redesigned to address technical survey, having the same productivity of one of these 21 machines, while using only 300 units, which is only 1/100 of the tractors available, we could potentially solve or dramatically reduce the problem in less than 1 year.